Hi, welcome to Professional Certifications channel. Let's break down CISSP exam preparation, one topic a day for focused and effective learning. Today's topic is session management.
Definition. Session management refers to the process of securely managing the state and interaction between a user and a web application or service after the user has authenticated. Once a user has logged in, a session is created, which allows the system to remember the user's state, e.g., logged in, privileges, preferences, throughout their interaction with the system. Effective session management is crucial to ensuring that only authenticated users can maintain access to resources and services without needing to re-authenticate for every interaction.
Key concepts.
1. Purpose of session management. Session management ensures that authenticated users can access a web application or service securely over a period of time without re-entering credentials for each request. It maintains the user's state across multiple requests. It also controls session lifecycle aspects, such as session creation, maintenance, and termination, while preventing unauthorized users from hijacking or tampering with sessions.
2. Session creation. Once a user authenticates successfully, a session is established. The session typically includes a session ID, which uniquely identifies the session. The server assigns this session ID to the user, and it is passed back and forth between the client and server for the duration of the session. The session ID is often stored in a cookie, URL, or hidden form field, depending on the application.
3. Session ID. Session ID, a unique identifier assigned to a user's session. It is usually randomly generated and serves as a token to track the user's state across multiple requests. This ID must be protected to prevent attackers from guessing, stealing, or tampering with it. Characteristics of a secure session ID. Randomly generated and unique. Long enough to prevent brute force attacks. Sent over secure channels, e.g., HTTPS, to prevent eavesdropping.
4. Session management lifecycle. The session management lifecycle consists of several phases. Session initialization. A session is initiated when a user successfully authenticates. The server generates a session ID and establishes the session. Session maintenance. The server tracks the user's interactions by associating the session ID with each request. The client browser typically sends the session ID with each HTTP request, allowing the server to identify the user. Session expiration. Sessions should automatically expire after a period of inactivity to reduce the risk of session hijacking. Sessions can also expire when the user logs out or when a system administrator terminates the session. Session termination. The session is terminated when the user logs out or when a security event requires immediate session invalidation, e.g., an account is compromised.
5. Key session management practices. Session timeout. Sessions should automatically expire after a set period of inactivity, e.g., 15 or 30 minutes. This helps mitigate the risk of session hijacking if the user forgets to log out or leaves the session unattended. Example: if a user is inactive for 30 minutes, the session is terminated, and the user must log in again to continue. Secure session IDs. Session IDs should be generated using secure random number generators to ensure uniqueness and unpredictability. They should be long and complex enough to prevent brute force attacks. Example: session IDs should have at least 128 bits of entropy for security. HTTPS-only transmission. Session IDs should only be transmitted over encrypted channels, e.g., HTTPS, to prevent interception by attackers. The secure flag should be set for cookies containing session IDs, ensuring they are only transmitted over secure connections. Example: if a session ID is sent over an unencrypted HTTP connection, an attacker could intercept it and use it to hijack the session. Session fixation protection. Session fixation attacks occur when an attacker forces a user to use a specific session ID. To prevent this, the server should regenerate the session ID after successful login. Example: when a user logs in, the system generates a new session ID, preventing attackers from using a predetermined session ID to hijack the user's session. Session logout. Users should be able to terminate their sessions manually by logging out. A proper logout process destroys the session and invalidates the session ID, preventing further use of the session. Example: after logging out, any attempt to use the old session ID should fail, and the user must re-authenticate to access the system.
6. Security risks in session management. Session hijacking. If an attacker steals a valid session ID, they can impersonate the user and gain unauthorized access to the system. This can occur if session IDs are transmitted over unsecured channels or are guessable. Example: an attacker intercepts a session ID over an unsecured Wi-Fi network using packet sniffing tools and uses it to hijack the session. Session fixation. In a session fixation attack, an attacker tricks a user into using a known session ID. Once the user authenticates with this session ID, the attacker can hijack the session by using the same ID. Example: an attacker sends a user a link containing a specific session ID. When the user logs in with that session ID, the attacker can use it to access the user's account. Cross-site scripting, XSS and XSS attacks. An attacker injects malicious code into a web page viewed by the user. The malicious script can steal session cookies or session IDs, allowing the attacker to hijack the session. Example: a malicious script steals the session ID stored in a cookie and sends it to the attacker's server. Session replay. An attacker captures a legitimate session and replays it to gain unauthorized access. Without mechanisms to detect and prevent session replay, attackers can reuse captured session tokens. Example: an attacker replays a session token they intercepted to bypass authentication and gain access to sensitive data.
7. Session management best practices. Regenerate session IDs on login. Ensure that a new session ID is generated when a user logs in to prevent session fixation attacks. Invalidate sessions after logout. When a user logs out, the session should be destroyed, and the session ID invalidated. The session ID should no longer be valid for further requests. Use HTTP-only and secure cookie flags. Mark session cookies with the HTTP-only flag to prevent client-side scripts from accessing them and with the secure flag to ensure they are only transmitted over HTTPS. Limit session lifetime. Limit the maximum session duration, even if the session is active, to reduce the window of opportunity for session hijacking. Detect and monitor suspicious sessions. Implement security monitoring tools that can detect abnormal session behavior, such as multiple logins from different locations using the same session ID, and terminate such sessions.
8. Session management in single sign-on (SSO). In single sign-on (SSO) systems, a session established with one service or system is used to authenticate the user across multiple systems. Effective session management is critical in SSO environments because a compromised session could grant access to multiple services. SSO systems must ensure secure handling of session tokens and enforce centralized session timeout and logout across all connected services.
9. Session management in APIs and web services. For application programming interfaces, APIs, and web services, sessions are often maintained using tokens, such as OAuth or JWT. Secure session management in APIs requires protecting these tokens from theft, ensuring they are transmitted over secure channels, and refreshing them regularly to prevent misuse. Token expiration. API tokens should have short lifetimes to minimize the impact if a token is compromised. After expiration, a new token must be issued.
Importance in the CISSP exam. Session management is an essential topic within the Identity and Access Management (IAM) and Security Operations domains of the CISSP exam. CISSP aspirants must understand how to securely manage sessions, mitigate session hijacking risks, and apply session management best practices in web applications, APIs, and enterprise systems. Exam questions may focus on session lifecycle management, secure transmission of session IDs, and protection against session-based attacks.
Real-world example. An e-commerce platform implements secure session management by requiring all session IDs to be transmitted over HTTPS, automatically expiring sessions after 15 minutes of inactivity, and regenerating session IDs upon user login to prevent session fixation attacks. Users can also manually log out to terminate their sessions, ensuring that no unauthorized user can reuse their session IDs.